Hey, pre-calc students, this is Mr. Mitchell. We're going to take a look at properties of logarithms. Last time we looked at logarithms and their graphs. This time we're going to look at some different properties, change of base formula, expanding and condensing logarithms for solving equations, for simplifying, and doing some other things like that. So there's a lot of information at the top here, nothing for us to write in, but stuff for us to refer to. So approximate values using change of base formula. So this hasn't been as important because if you have a really new calculator, you don't need to do the change of base formula, but not everybody has that luxury. So we want to do log base 5 of 25. So sometimes we can do wagon wheel and figure that out. But I don't think we can do wagon wheel because 4 to some power never equals 25, like a nice round integer number. So to do the change of base formula, you take the log of the larger font size number and you divide by the log of the base number. So this is always written as a larger size font. That's what I mean by font. And then this is always written as a smaller subscript. So it's always the log of this divided by the log of this. Now, we're going to use log base 10. We need to use something that we can calculate with a calculator. So it either needs to be, if you look at, for letter C and D, we're going to do natural log. We either need to do log base 10 or log base E, natural log, because that's all our calculator can do directly. So I pull up my calculator. I'm going to do the log of 25 divided by the log of 4. And I get 2 point, what are we supposed to round to again? The nearest 4 places? Okay. So we're going to go to 2.3219. So that equals 2.32. Okay. So now we're going to do log base 2 of 12. Again, we would think about doing wagon wheel here. 2 to some power equals 12. I don't know what that is. It's some ugly decimal, so I can't, there's not much I can do with that. So we're going to do log base 12. I'm sorry, log of 12, not log base 12. It's base 10 over log of 2. And then we're going to go to our calculator. And we're going to go log, what do I keep hitting second? Log of 12 divided by the log of 2. 3.5850, actually, if you round it correctly, 3.5850. So it's 3.5850. Well, now for C and D, it's the same. We should get the same answers, and we do. But we're going to take, instead of log base 10, we're going to do the natural log. The natural log of 25 divided by the natural log of 4. And then we're going to do the natural log of 12 and divide by the natural log of 2. We should get the same answers, but let's verify that. So we're going to go natural log of 25 divided by the natural log of 4. We get the same answer as the first one, right? And then we're going to take log base 12. Sorry, natural log of 12 divided by the natural log of 2. And we get the same thing both times. So just be aware of that. You can use the natural log or the log base 10. It doesn't really matter as long as you're using, so you could use log base 7, but that doesn't help us. It's not in the calculator. It has to be something that we can do in our calculator that's to be helpful. Otherwise, changing the base doesn't make any sense. You can change the base to something else if you need to. Okay, example 2, write each logarithm in terms of natural log of 2 or the natural log of 3. So I need to think of my properties up here. When you have one log, it separates into 2 logs with addition. If you have one log with division, it separates into 2 logs with subtraction. And then if you have a log of a power, the power can be written out front. Those are all important properties that we need to be aware of. They work for regular logs or the natural log. It doesn't matter. They both are the same. So I see the natural log of 6. How could I get 6? Can I multiply to get 6? Can I divide to get 6? So we want to use in terms of log base or natural log of 2 and natural log of 3. So how do I get 6 from 2 and 3? Well, you multiply. So it's really the natural log of 2 times 3. Then we have a property up there that says if you have one log, you can split it into 2 logs through addition. So it's the natural log of 2 plus the natural log of 3. And that's it. So now here we have the natural log of 2 divided by 27. So remember, we have a property up above. If you have one log being divided, here we go, one log being divided, could be natural log. It separates into 2 with subtraction. So we're going to have the natural log of 2 minus the natural log of 27. But that's not in terms of the natural log of 2 and the natural log of 3. This is, so that's kind of done. It's the natural log of 2. Can I rewrite the natural log of 27? Well, what's 27? Isn't 27 3 cubed? It is. So this is really minus the natural log of 3 cubed. Well, we have another property. Again, scrolling up again. If you have a power, you can write that power out front. Well, let's do that. So we're going to have the natural log of 2 minus 3 times the natural log of 3. And now it's written in terms of the natural log of 2 and 3, using our properties. Part C says, rewrite and simplify the logarithmic expression. So we have one log with 2 things being multiplied. The 6 is a power, so that's not being multiplied, that's to a power. So this is really the natural log of 5 plus the natural log of e to the 6th. All right. But for these directions, we don't have to make it in terms of the natural log or 2 or 3. That direction was just for A and B. So now, I don't think we can do anything with a natural log of 5. That's a calculator thing if we need to simplify it or break it down further. But this properties that we just used over here says I can write that 6 out front. And then what happens, what's a natural log of e? The natural log of e, those are inverses of each other, so they just cancel out. So it's just gone. It's just the natural log of 5 plus 6. Everything else just canceled. Boom, it's gone. We're using our properties. We've got to keep those properties in mind and continue to use them. So letter D said, or the directions say find the exact value of each expression without using a calculator. So this is using our properties. Now, if you could have a calculator, you can obviously evaluate it. But for right now, we're practicing using the properties because for certain things, our calculator won't do them. So we have to know the properties. If it is a calculator question, well, then just use a calculator. You don't need to use properties. But for practice purposes, we need to be able to do this kind of stuff. So what is log base 5? What's a cube root? Think about exponents. A cube root is a 1/3 power. Yes, again, we need to know our exponent rules from before. So this 1/3 can be written out front. So it's 1/3 log base 5 of 5. What's log base 5 of 5? Remember, we learned that before. What is log base 5 of 5? If you set it equal to x, 5 to the x equals 5. What's x got to be? Well, it's 1. So this whole thing is just 1. So it's 1/3 times 1, which is 1/3. Fair enough? Not too bad? Okay. So letter E is interesting. You can do it a couple different ways. Depends on how you see it. You can see that it's 2 logs being subtracted. So let's put it together as 1 log. And you're going to use division. So it's e to the 6th over e squared. Well, knowing your exponent rules, it's actually the natural log of e to the 4th, not e squared, e to the 4th. And we have a property that you can write the 4 out front. Natural log of e. And then natural log of e cancels, it's just 4. You could also use the power property right now. Bring the 6 out front. So you could do this way, or bring the 6 out front. So you have the natural log of e minus, bring the 2 out front. Well, what happens to the natural log of e? They both cancel. So what's 6 minus 2? 4. Either way, you're getting 4. Okay, this one's thrown in here a little bit just to think about, you could do wagon wheel, or you could think of 9 and 3. Can we make the base the same as the of number? Isn't 9 3 squared? So it's log, well, first we write the 2 out front. So 2 log base 3 of 3. What's log base 3 of 3? Well, what was log base 5 of 5? 1. So it's log base 3 of 3. 1. So it's 2 times 1. Just 2. So again, using my properties, you could do wagon wheel and do that one as well. You're going to find that it's 2. So you have choices. Knowing your properties can be very helpful. For this particular problem, you could even use the calculator and you're still going to get the right answer. So you got choices there in letter F. Why are we practicing our properties? Well, it's for these types of questions that we need to know our properties for the second page here. We need to expand. So we're sometimes going to condense and sometimes we're going to expand our logarithms. So I have one log with 1, 2, 3 things. That 3 is connected with the x, so it's not its own separate 3. That's a power. So I'm going to write this as 3 separate logs, because there's 3 separate things. Base doesn't change. I have to carry that forward. All the bases have to stay the same. And they're all separated with addition. Now, the only other thing I need to do, the 3 needs to be pulled out front. The other stuff, you can't do anything with it. It's simplified all the way. You might say, well, what's the point of this? Well, when we're dealing with regular numbers, we could break these down further. And when you do certain things in calculus, you want things to be expanded so you can look at them individually. So we're learning those types of things for when we get to regular calc. So now we have a natural log. The rules are not different for log with other bases than the natural log. So I have a top and a bottom with one log. That means I have 2 logs. They're going to be separated by subtraction. So I have the top, and then I have the bottom. So what is a square root? A square root is a 1/2 power. What do I do with a power? Write it out front. Natural log of 7, you can't do anything with. You can't do anything with this 3x minus 5. Make sure you put that in parentheses, though. Should be in parentheses, so it signifies that this is all inside that natural log. Okay? And then you have the natural log of multiple things. Well, how many things do you have? 1, 2, 3. The z is squared, so it's not its own separate thing there for the 2. So you have 3 natural logs, and they're being separated with multiplication. So you're going to have 3 separate logs with addition. So the natural log of x is done. Natural log of y is done. I got to pull that 2 out in front of that other natural log. So that's expanding. We're expanding for certain reasons. In a second here, we're going to be condensing. But again, we go back to these properties. It's all based on right here. These are all the properties. There's not that many, but you got to know how to use them. So now let's condense. We've got to combine logs together. All right, so first we're going to deal with the numbers out in the front. So this is going to be the log of x squared plus the log of x plus 1 cubed. We got to keep that in parentheses there. And now we have 2 logs. Well, we're going to put them together as 1. 2 logs separated with addition means multiplication. So you're going to get x squared times x plus 1 cubed. Now, sometimes it's okay to leave your answer like that. Sometimes you'll have to go further. For our class, I will clarify, if it's a solving equations, you'll have to go further. If it's just a condense or an expand, I will tell you that you don't necessarily have to multiply everything out, or that you will, because this could get a little messy. This is time consuming. You got to write it out 3 times. You got to FOIL all that stuff and then multiply by x squared. Not really what I'm trying to test you on or get you to see if you know how to understand it. So we're not going to worry about that right now. Let's take a look at letter B. We have 2 natural logs separated with subtraction. They're going to go together with the division. But now we need to deal with this 2. So we're going to write this 2 as a square. So now I have two natural logs being subtracted. That's going to turn into one natural log with division. So you have the top, and then you have the bottom. So again, sometimes that'll be okay to leave, and then other times it won't be. Let's just practice. This one will take as long, but you're going to multiply the top out. It's going to be x squared plus 4x plus 4. Again, you have to write this out twice. It's x plus 2 times x plus 2. Nothing cancels, so you wouldn't necessarily have to multiply it out unless it was for something else. So showing me this tells me that you can condense logarithmic expressions. That's what I'm looking for. All right. If it's a solving equation, you're probably going to have to go further. So it just depends on the situation. All right. Take a look at this one. We have two logs being added with a cube root on the outside. So notice the difference. This one, the 1/2 was just with this first log, not the second. This one has both of them on a cube root. So we're going to leave that to the end. We're going to leave the 1/3 alone for right now. We have two logs that need to go together. They're going to become one log with multiplication. So it's going to be x times x plus 1. Let's multiply that out just so we can get a little practice with what we might have to do. That's going to be x squared plus x. And then what do we do with the 1/3 power? Oop, I forgot my base, didn't I? Sorry, it's log base 2. Don't lose the base. You got to keep that because that means something different if I forget that too. So we're going to have a log base 2. What's a cube root? It's going to be the cube root of all this stuff on the inside, x squared plus x. I skipped a step there. Technically, it should be, maybe I shouldn't skip any steps, but it should be x squared plus x to the 1/3 power, and then you get that last step. So you go from here to here. So if you're good enough and you understand everything, you can go from here to here. I shouldn't have skipped that step, just learning it in our notes. All right. So now take a look. I got a log being subtracted by another log. That's going to go together with division, but notice I do have a 2 here, so I'm going to have to deal with that first. So I need to make that squared. And then 2 logs go together as 1 with division. And for our intents and purposes, we practiced multiplying things out. Since this is just a condensed problem and there's nothing else to do, we're going to leave it like that. If it were a solving equation, you would have to go further. You would have to multiply this stuff out on the bottom. It's just x squared plus 2x plus 1. Have to do a FOIL, but it's not anything too excruciating, just a little time consuming. So if you have any questions, that is properties of logarithms, mostly combining and condensing. Those, where are we headed next section, next concept is solving equation. You need to be able to use these properties to solve equations. Some of these questions aren't realistic that you're ever going to have to do them after you practice, but you have to learn the properties in order to be able to apply them. So let me know if you have any questions.